Hello, trig class. In this video, we review section 9.7 by taking a look at the practice test. So let's get started. First one asks me to find the dot product, and so I'm just going to make this dot a little bit more clear that that's a dot there. So this is a vector, that's a vector. If you dot the two vectors, you get the dot product, and that's defined to be the multiplication of the first component plus the multiplication of the second components. So that gives you a minus 81. Remember, if you write this in terms of I and j, that still makes the same components. So u is the same as the components minus 5 and minus 8. And if you dot that with v, which has the components 7 minus 6, then as above, as we just did, you'd take and multiply the first components together. So that's a minus 5 times a positive 7, and a minus 8 times a minus 6. So you get a minus 35 plus 48, so that's 13. All right, let's keep working. All right, this is just dotting a vector with itself. So these are defined as steps here, but steps kind of give you the feeling like you'd use the first step, do the second step, you'd use this third step, do the second step. You don't. These are like just 4 separate problems, like an A, B, C, D. They're not related. Okay, so if you go v dot v, that would be 5 minus 8 dotted with 5 minus 8. So you'd multiply each of those first components together, add on what you get when you multiply each of the second components together. And that would give you 25 and 64, which is 89. Okay. Well, let's keep going. Like I said, these aren't really steps. They're just separate problems. All right, if you're going to do 3u times v, 3u, and then dot it with v, you could do 3u first. Then dot it with v. So that would be 3 times the vector minus 5 minus 9. And then after doing that, you would dot it with v, which is 5 minus 8. So multiply the 3 through into each component, because that's how scalar multiplication works. And you get minus 15 minus 27. Now we've got 2 vectors that are being dotted. So we multiply the first components. So you get minus 75 for that first component. And then, let's see, looks like 216 when you multiply the second components, and then you add them together. So that should be 141. Okay. All right, this is a number, because if you measure the length of the vector, that's a number, and then after you get that number, you're supposed to subtract 3. So let's measure the length of v, and after we do, let's subtract 3. The length of v is the length of the vector, because we're given v, 5 minus 8. After you go get that length, I subtract the number 3. And the way you get the length is you sum the squared components. So you square each of these components, then you add it together, and then you take the square root. And after I've noted that, I'm going to subtract the number 3. So this would be the square root of 25 plus 64 minus 3, or the square root of 89 minus 3. That's the third problem under number 3. Then lastly, let's do u dot v times 3v. So u dot v and then times 3v would be, we're given the u, it's a minus 5 minus 9. And we're supposed to dot that with v, which is a 5 minus 8. Okay. Then we multiply that with number 3 and then the vector v. And it doesn't matter the order that you do that. I'll do the multiplication of the 3 through the vector v first. But I'll dot these two guys before I do that. So you get a minus 5 times 5 plus a minus 9 times a minus 8. And that'll be a number. And then you're going to multiply the number 3, which is multiplying the vector v. And we're given that vector v is 5 minus 8. 5 minus 8. So we'll just stick it in there. Okay. This is just multiplication. It's not dot product. It's not like that one. So that would be a minus 25 plus 72. And I'm going to multiply that number times, go ahead and multiply this through. And that'll give me a 15 for 3 times 5, and minus 24 times 3 times a minus 8. All right, now if you take minus 25 and 72, that number is 47, I believe. And then you still have times 15 and minus 24. And this is times here, it's not dot. Because this is just a number, it's not a vector. We can only dot two vectors. The number times a vector is just the number times each component. Okay, and that would be times 15 minus 24. So the first one would be 47 times 15. And the next one would be 47 times minus 24. And if you multiply those numbers on the inside there, you'll get 705 and minus 1128. All right, so that's number 3. Let's move to the back side. All right, it says find the magnitude of u using dot product, so I will, but you wouldn't have to use dot product to get it. You just use the definition of magnitude. What they want me to remember is that if you dot two vectors, dot the vector itself, you get the same thing as if you get the length of the vector and then square it. So they want me to first get this guy And then to get the magnitude, I'll just take the square root to get that square root sign to go, or that square to go away. So u dot u would just be, and this is a dot here, minus 3 times minus 3 plus 5 times 5. That's 9, and 25 is 34. That's u dot u. Should say that's u dot u. So if I want the magnitude, I need to get rid of that square. So I just take the square root of both sides, and I'll say that the square root of 34 is square root of length of u squared. And that's my length. All right, this one is maybe the most popular problem that you'll have in the section. It's given two vectors, how do you find the angle in between them? So put the tails together, and let's say the angle between them is theta. Then we know by the theorem on that relates the lengths of the sides to the dot product of the angle. We know this relationship, that if you dot two vectors, you'll get the length of each multiplied times the cosine of the angle in between. So, okay, u dot v. This guy's going to be 1 times 4, and then plus 6 times minus 9. Because that's how you dot. The length of u would be the length of that, but we know that to get the length of the vector, you just sum the square of the components. So here's I'm summing the square of the component, square root. Do the same thing with v. It's 4 squared plus a minus 9 squared. And it's still times the cosine of the angle. Okay, so this is a 4 and a minus 54, so that's a minus 50. This guy's square root of 37. This guy is 97, because it's 81 and 16. Yeah, so that's square root of 97. That's times the cosine of your angle. So if you solve for the cosine of the angle, it's minus 50 over the square root of 37 times the square root of 97. So to get that angle, you just have to use a calculator and do the inverse cosine. And if you do that, you'll get theta is the inverse cosine of minus 50 over the square root of 37 times the square root of 97. And that's approximately, using my calculator, 146.58 degrees. Okay. Same deal here. We're going to use that relationship for the angle between two vectors whose tail is put together. And we will do that in the next video. See you there.